Okay, everybody, now we're going to do the product and quotient rule, section 2.4. The product rule is when you take the derivative of a function which is a product. So if you have a function which is f of x times g of x, I'll give examples of all this. The derivative is going to be f times g prime plus g times f prime. F prime g plus g prime f plus f g prime. So I'm going to show you, I'm going to go through the proof. So capital F is this product, and the derivative is, that's our tattooed function. But capital F means f of x plus times g of x. And what we're going to do is we're going to subtract f of x plus delta x g of x, and then we're going to add back f of x plus delta x g of x. Once we do that, that allows us to separate this fraction into two separate fractions. Now, when delta x goes to 0, this sucker here, this guy, that just disappears, becomes f of x. But this is the derivative of g. That's my g prime. The g stays g, and this part over here becomes f prime. So it's f times g prime of x plus g of x times f prime of x. And that's the, now if you didn't follow that, don't worry about it. That's the derivative of this very important formula. But let's actually do it now. Now, why do we do it all together? Because it makes it easier to take a derivative. Instead of having to multiply this whole thing out, I could do the product rule. Here's my first function, that'll be my f. That's my second function, is my g. So it's the first times the derivative of the second plus the second times the derivative of the first. Well, the derivative of 5 plus 4x is just 4. The derivative of 3x minus 2x squared is 3 minus 4x. So the answer is now just automatically going to be 3x minus 2x squared times 4, which becomes 12x minus 8x squared. Plus, if I just FOIL this out, I get 15 minus 8 x minus 16x squared. And if I just combine like terms and so forth, I get 15 plus 4x minus 24x squared. And pal, that's my answer. And that is using the product rule to get an answer. And here, I can use the product rule again. The derivative of, now I'm going to rewrite 1 over x as x to the negative 1 power, because that just makes it easier to differentiate. And f prime is going to be the first function times the derivative of the second, plus the second function times the derivative of the first. So that's going to be x to the negative 1 plus 1, just times plain 1. And now x minus 1 times negative x to the negative 2. Now, when I rewrite this and, and distribute everything and turn it back to fractions, it becomes 1 over x plus 1 minus x minus 1 over x squared. And then I can put this all into one giant fraction, cancel the x and the minus x cancel, and I'm finally left with x squared plus 1 over x squared, and that's my final answer. And that, my friends, is a thing of beauty, which is a joy forever. It says that somewhere. Alrighty.
Big boss. Big boss. You see the hole in one?
Now we're going to find the derivative of these guys here. Okay, so y equals 2x times x squared plus 3x, and y equals 2 times x squared plus 3x. Now, by the way, we could, instead of using the product rule, we could just distribute the 2x into the parentheses and do it straight. And either way is fine. The point is that calculus gives us a variety of methods to do. Usually, a problem will often have more than one way to do it. Anyway, so here's the first function times the derivative of the second function plus the second function times the derivative of the first function. So it's 2x times 2x plus 3, because that's the derivative of this guy, plus x squared plus 3x times 2, because that's the derivative of that guy. Combine everything, you get 6x squared plus 12x. Now, the next one is just plain 2 times that same parenthesis, and that's just going to be using the constant multiple rule. It's just going to be 2 times the derivative of the parenthesis, and that's going to be 2 times 2x plus 3, which is 4x plus 6. Pow, that's it, done. And what a difference an x makes.
A new day.
Okay, now there's another rule called the quotient rule. And the quotient rule says if I have a derivative of a quotient, it's going to be g times f prime of x minus f times g prime of x over g of x squared. So it's a little similar, but a little different to the product rule. And the derivation is kind of similar. I'm going to add it. I'm going to set this up, combine fractions, subtract and add the same thing, split up the two fractions. It all kind of goes, I'm not going to go through the super lengthy, but it all boils down to this guy right there, which is g times the derivative of f minus the first function times the derivative of the second. Notice it's minus, not plus, and then over g squared, whatever g is. G is the denominator of the function. Let's actually do a couple of, let's actually do some examples and make more sense. So f is my top function, x minus 1. G is my bottom function, 2x plus 3. And now we're going to do it. So I'm going to do the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And when I multiply all that out, I get 2x plus 3 times 1 minus x minus 1 times 2. And then on top, the 2x's wind up canceling, and I just get 5 over 2x plus 3 squared. And that is the answer. That is the derivative of this is that. And that's pretty kind of cool and awesome, I must say. It's kind of cool and awesome. Okay, let's carry on. That's really interesting, actually, when you think about it. I'm just gonna pause this for a second and think about this. Let me pause. Now I'd like to find the equation of the tangent line. So we have the function y is equal to this polynomial on top over that little polynomial on the bottom. We want to find the equation of the tangent at the point 1 comma negative 1. Well, I'm going to take the derivative, dy dx. So I take the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. I do a lot of crunch until I finally get negative 6x squared plus 8x plus 1 over 8 minus 2 minus 3x squared. Now, we want to find the slope at the point, and this is the derivative now. So we want to find the slope at the point 1 comma negative 1. So basically, I just have to stick x equals 1 into this, and that's going to give me what I'm looking for. So I stick in x equals 1, I get 3, which means the slope, which is I want a line whose slope is 3 and goes to the point 1 comma negative 1. So I just use the point slope formula, and then I simplify it. I wind up getting y is equal to 3x minus 4. And here is the function we're talking about. This is that big ugly kind of hyperbola-ish function, and that's the tangent line through the point 1 comma negative 1. So without calculus, there's no way to be able to do this problem. With calculus, it's just a matter of just steps and crunching. Okay, moving forward. Find the derivative of y equals 3 minus 1 over x plus 5. So we want to begin by rewriting the function, and then we want to apply the quotient rule. So I'm going to rewrite this as I'm going to multiply top and bottom by x, and I get 3x minus 1 over x squared plus 5x. And that's because I don't want to deal with fractions inside fractions. And now I take the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. I combine like terms and multiply out, combine like terms, and I get negative 3x squared plus 2x plus 5, and that is my derivative for this ugly function. This is really amazing because without the quotient rule, I mean, how else? Like, I wouldn't even know where to start a problem like this. Okay, let's look at constant multiple rule. Well, we know that already, don't we? Well, this here is just take the derivative of the top. Well, here's our function. Write it as 1/6 of this guy. Take the derivative of the inside and multiply it by that same 1/6, and then just distribute it, and I get 1/3 x plus 1/2. Here I take 5/8 x to the 4th. Move the 5/8 out as a coefficient, The derivative of x to the fourth is 4x cubed. Then multiply 5/8, simplify, I get y prime equals 5/2 x to the third power. Now here I'm going to pull out the -3/7. I'm going to divide everything. We're going to cancel out some x's here. I have 3 minus 2x times -3/7. Take the inner derivative, which is just -2, times -3/7. And I get y prime is equal to 6/7. That's very fascinating. That is very fascinating. That the derivative here is just going to be 6/7, no matter what. Which makes sense actually because it's a straight line. Straight line has a slope all the way through, constant slope. Why do I say constant slope? Because no matter what x is, the derivative is 6/7. So at every point, the slope of a tangent is 6/7, which means the curve itself is just a straight line. That's why. Now I have 9/5. I'm going to rewrite the x squared here as x to the -2 without the fraction bar. And now I just take the inner derivative. It's -2x to -3. Simplify everything and get 18, -18 over 5x to the third power. And that is a thing of beauty. A thing of beauty is a joy forever. Okay, yuck. Rate of change of systolic blood pressure. Blood pressure, if you know, there's two numbers. They say you like 120/80 or something like that. The systolic is the top number, in case anyone cares. The diastolic is the bottom number, in case anyone cares. Anyway, but blood moves from the heart through the major arteries out to the capillaries and back to the veins. The systolic blood pressure continually drops. Consider whether, hold on a second, please. So the blood pressure P is equal to this big ugly fraction here. And we want to know what rate the blood pressure is changing 5 seconds after blood leaves the heart. So basically, we're going to take the derivative and we're going to plug in t equals 5. That's really all we're going to do. So, and we're going to use, and since this is a big quotient, we're going to use the quotient rule. That's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Combine like terms. A bunch of things cancel here, and we get. Just get -200t over t squared plus 1 squared. And now, if you want to know, now just plug in t equals 5. And I get 200 times 5 over 26 squared, which is approximately -1.48 millimeters of mercury per second. And that is awesomely cool. So that's our product rule and our quotient rule. And now we have some beautiful homework that we're going to give you. I'm going to be putting the homework up as usual. I'm going to be putting the homework up on Canvas. Because I know you guys love doing homework. Who wouldn't love doing homework? That, my friends, is the story. See how much fun that was? That was like loads of fun. It's been absolutely delightful. And I will see you guys next time. Bye, everybody. Bye.